This video will be the introduction to writing proofs regarding circles. Now, you'll need to recall much of the information that we've learned about angles in order to pull that into the proofs that we're going to write regarding circles. For instance, you would need to know that congruent central angles have congruent arcs, and that congruent arcs have congruent central angles. Here's what that means. In this picture, we're told that these central angles are congruent to one another, and if their central angles are congruent, then the arcs must be congruent as well. So in other words, what this is saying is if angle 1 and angle 2 are congruent central angles, then as a result of that, the arc that goes with central angle 1, or arc AB, is congruent to the arc that goes with central angle 2. I'm going to call that one arc CD. And the reverse of this is true also. When arc AB is congruent to arc CD, as a result of that, central angle 1 is congruent to central angle 2. It makes sense because the degree measure of the central angle is equal to the degree measure of its arc. All right, the next one that you need to be aware of isn't one that you've seen before, but it's not terribly difficult. This just says that congruent central angles have congruent chords, and when chords are congruent, the central angles that go with those chords are congruent as well. So in other words, what they're telling you here is that these green angles, which again I'm going to call angles 1 and 2, when those guys are congruent, the chords, and if I'm going to think about that as the chords that would connect their arcs, have to be congruent as well. So again, when angle 1 is congruent to angle 2, their chords, AB and CD, are congruent as well. And when the chords are congruent, we know too that the central angles must also be congruent. So that too is not terribly difficult. It should feel fairly, should feel good inside. It should feel right. All right, the next one too should be pretty intuitive. It says congruent arcs have congruent chords. So in other words, when those blue arcs between CD and AB are congruent, their chords, which are chord CD and chord AB, have to be congruent as well. So again, when arc CD is congruent to arc AB, we know that chord CD is congruent to chord AB. And the reverse of that is true as well. When the chords are congruent, we know that as a result of that, the arcs have to be congruent as well. The next one is fairly intuitive. Congruent inscribed angles have congruent arcs, and likewise congruent arcs have congruent inscribed angles. And they didn't make a little picture here, so I'm going to go ahead and draw one. And I'm going to draw a picture of two congruent inscribed angles, so maybe I would make that angle 1 and angle 2. And if those two angles are congruent, the arcs that go along with those two angles have to be congruent as well. And I might call those 3 points A, B, and C just so that I can talk about them. So when the inscribed angles are congruent, the arcs are congruent. And likewise, when the arcs are congruent, we know it must follow that the inscribed angles are also congruent. And if you remember what you know about the connection between inscribed angles and their arcs, it should be fairly obvious why that's true. Inscribed angles that intercept the same arc are congruent. So here's what that's saying. Inscribed angle A and inscribed angle C both have for their arc DB. And therefore, since they both intercept the same arc, their degree measures are half of that arc and would have to be equal to one another. So that's what that's saying. Likewise, inscribed angles D and B both share the purple arc, and because they both share the purple arc, they too are congruent to one another. So angle D is congruent to angle B because they're inscribed angles that share the same arc. Angle A is congruent to angle C for the exact same reason. The next one, all radii of the same circle are congruent. So what this is saying is that if OA is a radius, and OB is a radius, and OC is a radius, and OD is a radius, all of those radii have to be congruent. And you've seen that. You know that no matter where you draw the radius in the circle, it's always the same. And then the last one, an angle inscribed in a semicircle is a right angle. Well, if you think about that, any inscribed angle is going to have a degree measure equal to half of its arc. The arc for angle B is 180 degrees, making the degree measure of that angle half of 180 or 90 degrees. And that's why the angle that's inscribed in the semicircle is a right angle. So now that we've talked a little bit about the reasons, let's go ahead and see how we might use some of these in a proof. In the first example, we're told that arc AB is congruent to arc CD, and I'm going to mark congruent arcs in the picture the same way I would mark congruent segments. And likewise, if we know that arc AB is congruent to arc DC, we know that chord AB is congruent to chord DC as well. So I'm also going to mark the chords. And we're trying to prove why triangle ABC would be congruent to triangle DBC. So in other words, why the yellow triangle would be congruent to the green triangle. And I already have one pair of congruent sides, the chords that were given to me by the arcs. I know that segment BC is shared in both of those, so that gives me a pair of shared sides by the reflexive property. And looking at the picture, looking at angle A and angle D, I notice that both of those intercept arc BC, so they must be congruent to one another. So at this point, I'm looking at this and I'm seeing side-side angle, which remember is not a method that you can use to prove triangles congruent, so I need to go ahead and keep looking. I do happen to notice that the inscribed angle for this blue arc over here, arc AB, its inscribed angle is angle 1, and the inscribed angle for arc CD is over here, angle 2, and since those blue arcs are congruent, I know too that their inscribed angles must be congruent as well. So now I'm seeing this as an angle-angle side proof, and I can use either of those pairs of congruent sides for my my angles. So angle-angle side is going to be my outline. I'm going to call this 3 and 4, just so I can have something to write about in my proof. Inscribed angles 3 and 4 are congruent because they share the same arc. Inscribed angles 1 and 2 are congruent because they intercept congruent arcs. And then you can either use chord AB congruent to chord DC because congruent arcs have congruent chords, or you can use segment BC congruent to itself by the reflexive property. Either one of those will serve you very nicely. I'm going to go ahead and I'm going to start with those congruent arcs. Arc AB congruent to arc CD. And as a result of those blue arcs being congruent, I know that angle 1 is congruent to angle 2. And the reason for that is those congruent arcs have congruent inscribed angles. And it's important that you use the vocabulary here. That word inscribed needs to be part of your reason. So that's done. I knew that angles 3 and 4 were congruent because they both intersect the same arc, BC. So angle 3 is congruent to angle 4, And again, they're inscribed angles, so I have to be very clear and specific about exactly which vocabulary I'm going to use here. Inscribed angles that intercept the same arc are congruent. And again, that word inscribed is really important. Segment BC is congruent to itself by the reflexive property. Or remember too that you could use those congruent arcs that you were given to say that chord AB is congruent to chord DC. That would work quite nicely as well. So I'm going to pull all three of these together. I've now talked about in my proof all of the things I needed to talk about in order to make my triangles congruent. And once the triangles are congruent, I know that all of their corresponding parts have to be congruent as well. So now I'm all poised to go ahead and to say that angle ABC is congruent to angle DCB. And I know I'm getting up there on about 12 minutes now. However, there aren't any check your understanding questions for this video, so I'm going to take the liberty of going a little bit further and doing this second proof. All right, this one too, I'm going to go ahead and I'm going to mark arc AC congruent to arc AD. And again, I like to, in addition to using the hash mark, I like to highlight because I think that makes it a little bit easier to see. The inscribed angle that goes along with arc AC is over here at D, and the inscribed angle that goes along with arc AD is over here at C. So once those arcs are congruent, I know their inscribed angles are congruent as well. In addition, segment AC and segment AD would be the chords that go with those, and they too are congruent. Segment BE is perpendicular to AC. Segment BF is perpendicular to segment AD. And B happens to be the midpoint of segment CD. And they want us to prove that segment EB is congruent to FB. So I'm thinking from the way we've marked this diagram, it looks pretty nice to, or pretty clear to see to me that we're going to prove those yellow triangles congruent by angle, angle, side. And once the yellow triangles are congruent, CP-CTC will give us the desired segments. So it'd be nice if this picture was a little bit bigger. I'm going to say the right angles at 1 and 2 are congruent. The inscribed angles at C and D, which I'm going to call 3 and 4, are congruent. And lastly, segments BC and BD are congruent by the midpoint. So that's kind of the outline or the gist of what I'm going to write about in my proof. So 1 and 2 were the right angles. I knew they were right angles because of the given perpendicular segments. So I'm going to start off my proof talking about those perpendicular segments. And we know that perpendicular segments always give to us angles that are right angles. So that makes angle 1 and angle 2 the right angles. I don't want to say they're congruent quite yet. And that's because the perpendicular lines make right angles. And now I can go ahead and say those angles are congruent to each other. So that's done. 3 and 4 were those little inscribed angles that I knew were congruent as a result of the arcs. So I want to go back and have a discussion about the arcs being congruent. And once the arcs are congruent, I know the inscribed angles that go along with those arcs are congruent also. So the congruent arcs have congruent inscribed angles. And again, it's very important that you use the vocabulary. Those have to be inscribed angles in order for them to be congruent. And then the last pair of congruent parts I want to talk about are segments BC and BD being congruent, and those are congruent as a result of the midpoint. And now I can pull all three of these together and I've got my congruent triangles. Just be careful and make sure you match up the congruent parts. So triangle ECB, I'm going to name the first one. Triangle FDB, I'm going to name the second one. And they're congruent by angle, angle, side. Now that they're congruent, all their corresponding parts have to be congruent. And I want to prove that part EB is congruent to part FB. So that's by CPCTC. I know I've gone long on this video, but I do want to mention one thing very quickly because I hope it's a connection that you'll see between some work that we're doing now in the circles unit and some work that we did back in the winter time. Notice that these blue arcs are congruent to one another, and as a result, the red chords are congruent to one another. That makes the triangle an isosceles triangle, making these base angles congruent to each other, which we found another way. We found because of the congruent arcs that those congruent inscribed angles were congruent. But again, I just wanted you to notice or pay attention to how those two ideas kind of tie together. We could have used either one of those reasons for making those inscribed angles congruent. All right, as I said a little bit earlier, there are no key ideas, there are no check your understanding questions that go along with this video. So I'm going to say, hey, we're done. Have a good one.